Well, hello again. Mr. Buckley here with problem number 10 from your Chapter 1 Geometry Self-Test. Got to kind of think about that when I say it. Make sure I'm saying the right thing here. This is from Geometry Chapter 1 Self-Test number 10, where we are asked to determine whether these numbers could be the lengths of the three sides of a triangle. So we're going to use a triangle inequality, which means that we have to make sure that any two sides are greater than the third side, and it has to work for every pair. So we're going to do that with A. Can 1, 2, and 3, if those are side lengths, can they make a triangle? And the answer to that question is no, they can't. And the reason why is because 1 plus 2 is equal to 3, and it needs to be greater than 3. Sure, 3 plus 2 is bigger than 1, and 3 plus 1 is bigger than 2, but 1 plus 2 is not bigger than 3, so that's not going to work. They all have to work. All those pairs have to be bigger than the third side, and it needs to be bigger than, not equal to. So that's where we have the violation here. B, we have a great look at this, a fraction and a square root. All right, so I'm going to simplify these things or evaluate them. Let's say evaluate them to see what numbers we're working with here. And these are the numbers we're working with. 13 over 5, which is 2.6. And then 4.37 is 4.37. And then the square root of 37 is 6.09. And I believe I rounded that up to be a little generous with this number here. And we'll find that all of these numbers added together, they do work. So if we do 2.6 plus 4.37, that is going to be bigger than 6.09. So 2.6, that's 2.6 plus 6 or 4.37 is going to be 6.97, which is clearly bigger than 6.09. So even though that I rounded up, it's still larger. And then 6.09 plus 4.37 is clearly bigger than 2.6, and then 6.09 plus 2.6 is clearly bigger than 4.37. And you would check that with the calculator. I'm just kind of doing it in my head here. But it's clear that that those are bigger. But the one you would want to be sure of is the 2.6 plus the 4.37. But I had already checked that before. So the answer to this question is yes. These three side lengths can make a triangle. C, we have square root of 5, square root of 6, or I'm sorry, square root of 5, 6, and the square root of 10. So I'm going to evaluate these again for decimals. And once again, I'm rounding all these up. So the square root of 5 is 2.24, and then the square root of 10 is 3.17. And these will not work. And the reason why is because 2.24 plus 3.17 is equal to 5.41, which is not bigger than 6. And I even rounded those up, too, so it's not even close. So these three sides cannot make a triangle because of this violation here. All the rest of them will work, but there's a violation when we try to add the square root of 5 and the square root of 10. That does not equal 6. We get 5.41. And I believe in your book it says that they can make a triangle. The answers in the book say that this answer is yes. It is actually no.